Okay, I'll continue to talk about a deep learning framework for lifelong learning. Let's review forward transfer. When learning a new task that is similar to a previous task, then a new task weights could be copied over as an initialization, and minimization of the loss function can only happen just on the new task Z. So previously similar tasks can really help to learn the new task. That's great. However, they also cause confusion when you are evaluating both 2 and Z together. This is very similar to identical twins. When you have met the first guy, let's say John, and you learn to recognize him, but then when you meet the second person, say Peter, and you said, yeah, that's John, it's very easy to learn. But then when you're told that's Peter, it's a different person, you say, what? They look so similar. So what can you do? You have to bring John back. At this time, you have to review John's image and Peter's image and compare them and try to resolve the confusion. And that's exactly what needs to be done here. So when 2 and Z are confused, then we have to use 2's data and Z's data together, try to minimize the loss on 2 and Z together. And we can freeze some links, unfreeze some other link, and we can do that without affecting other tasks. But when the error of the confusion cannot be reduced to a very small amount, we can recruit some new units and then try to resolve the error further. Now, I just want to mention that confusions is a way of negative transfer. So this is because you jump to the conclusion too quickly. If we look at the experiment result, that seems also to be very interesting. So here is the confusion reduction between O and 0. So that's the amount of confusion before doing any confusion reduction. This is the confusion reduction without network expansion using existing network. And this is the error will be reduced further with expansion of 5 nodes and with expansion of 10 nodes. So you can see that the confusions could be further reduced with using the data of 0 and O only. Next, we'll talk about graceful forgetting. So continual learning without forgetting is great, but what if we have very few nodes left when we learn the new task, say 3? In this case, we cannot reduce the loss on 3 to a very small amount. What can we do? Well, what we can do is we can select an unimportant task, such as task 0, to be gracefully forgotten. We set the b-value of those to be 0, and then still train on data on the 3. So in this case, we expect to see 3 will be improving while 0 will be gracefully forgotten. So here the experiment result. So the first part is you are training on task 3, and you can see the predicted performance is improving very slowly. And then you forgot task 0, unfreeze task 0's weights. And then you can see that task 3 improves very quickly while learning, and task 0 gets gradually, slowly forgotten. And this is a similar experiment result if you can forget both 0, 1, and 2. And you can see all these 3's get forgotten gracefully. So this kind of lifelong learning has a lot of parallel to human learning, especially with some issues in human learning. So the first phenomenon I want to talk about is like Rain Man. Just like the movie Rain Man, the guy has very good raw memory, but not connecting all these events very well. This could be modeled in our lifelong learning framework with a lot of free units. And all these weights are set to freeze very well, but there's very little forward or backward connection between these blocks. So therefore, all these things are learned individually. Another situation is about memory loss, especially with a recent event, such as in the Alzheimer's disease. And this is a situation where the previous events are frozen very well, but all these recent events are less, the b-value is smaller, and then also you have very little free units to use, and maybe there's also a neuron pruning. So in this case, it causes memory loss in the recent events. Another thing is about sleep deprivation and tired brain. So researchers often say during sleep, people replay a previous experience, and this is like confusion reduction during at the sleep time. And when you have a very tired brain, all these lifelong learning algorithms we talk about will perform poorly, and even optimization, minimization, loss function can perform poorly. So the result will not be very good. So we hope we talked about this deep learning framework for lifelong learning, and I hope you enjoy it. Thank you.